Hello everyone. Today I'll be starting with stoichiometry. That is, some people also call it stoichiometry. This is nothing but quantitative analysis of a chemical reaction. Supposedly, I take a reaction. A reacts with B to form C. So supposedly X moles of A react with Y moles of B. Now, how many moles of C are formed? Or if I'm only given X moles of A, then I need to calculate that how many moles of B are required to react to form C, right? To form how many moles of C. Let me take a very simple example. Supposedly, I take the example of decomposition of calcium carbonate, CuCO3. When we heat this compound, it gives out CaO plus CO2, that is calcium oxide plus CO2. As you can see, one calcium, 2 and 1, 3 oxygen and 1 carbon. This reaction is already balanced, so the stoichiometric coefficient of all these are 1. Similarly, if I take another example, the electrolysis of water, then now again a very simple example, electrolysis of water. Let me write here electricity, though we are not studying the reaction here. H2O. Now to balance this reaction, very familiar balancing, either I can do this or I can do this. This is now also this reaction is balanced if I multiply this equation by half in both the sides. So what are the stoichiometric coefficients? Here one is the stoichiometric coefficient of H2O, one is the stoichiometric coefficient of H2, and half is the stoichiometric coefficient of O2. Similarly, 2 is the stoichiometric coefficient of H2O, 2 is the stoichiometric coefficient of H2, and 1 is the stoichiometric coefficient of O2. Now, what are we asked about in exams in stoichiometry? So stoichiometry, as you all know, basically deals with quantitative estimation, quantitative analysis of chemical reactions. Now, in quantitative analysis, you may be asked to calculate mass of reactant, mole of reactant, or volume of reactant. Similarly, you might be asked to calculate mass of product, mole of product, and volume of product. Now, you might be given only one and may be asked to calculate the rest 5. Basically, it is given that one is given, you are asked to calculate 2 or 3, and the given value is sufficient. So let me fare it up on the board. Mass of reactant, any of these might be given and any of these might be asked to calculate. Mass of reactant, mole of reactant may be given, and volume of reactant may be given. Volume of reactant, right? Similarly, mass of product, mole of product, or volume of product may be asked. Now, let me draw the possible permutations and combinations. So this is it. Supposedly mass of reactant is given. Now mass of reactant is given, to in order to convert it into moles, while calculating we prefer to deal in moles. So while if I want to convert a mass into mole, I have already told you it is done by multiplying it by dividing it by molar mass. So I am supposing the molar mass of reactant, let me write here molar mass of reactant, whatever it is, equals to mR. Right, R is in the subscript, so I'd be dividing it by the molar mass of reactant. I'll obtain the number of moles of reactant. Let me represent it by NR. Now, as we all know, in stoichiometry there is one basic principle. Let me redraw this to make some space. As we all know, in stoichiometry there is one basic principle, that number of moles of reactant or number of moles of reactant equals to divided up by stoichiometric coefficient of reactant equals to number of moles of product and equals to stoichiometric coefficient of product. And this formula is true for on all the number of elements or all the number of participants in a reaction along with the products. So number of moles of reactant upon stoichiometric coefficient of reactant equals to number of moles of product upon stoichiometric coefficient of product. And even if our reaction has multiple reactants, supposedly A plus B plus C plus D forms E plus F plus G plus H. So this formula is true for Na upon stoichiometric coefficient of A, Nb upon stoichiometric coefficient of B. Nb is nothing but number of moles of B, and so on and so forth, equals to number of moles of C upon stoichiometric coefficient of C, number of moles of D upon stoichiometric coefficient of D, number of moles of equals to number of moles of E upon stoichiometric coefficient of E equals to number of moles of F upon stoichiometric coefficient of F, number of moles of G upon stoichiometric coefficient of G, and number of moles of H upon stoichiometric coefficient of H. This is true for n number of reactants and n number of products. There is no such limit. Now in case we are now from here we can easily obtain stoichiometric coefficient of product. We can obtain from the reaction. Stoichiometric coefficient of reactant we can get from the reaction. Number of moles of reactant are already we have calculated, and number of moles of product we have to obtain. So we can easily obtain by cross multiplying the stoichiometric coefficient of product on the right side, and we'll obtain the number of moles of product. Now we have reached here with number of moles of product. Now number of moles of anything can be converted into mass by multiplying it by molar mass, as you all know it. So number of moles of product would be multiplied by molar mass of product. Let me suppose the molar mass of product to be Mp, though I have already written it. Product to be Mp, right? So from here we'll reach the molar mass of product. Now the most simple is conversion from mole of reactant to mole of reactant. Now mole of reactant, if you are given supposedly N are the moles of reactant, so we are already here. We don't need to make any such conversion, multiplication or division. So we are already here. Number of moles of reactant divided by stoichiometric coefficient of reactant equals to number of moles of product upon stoichiometric coefficient of product. We already know the stoichiometric coefficients. Number of moles of reactant we already know. We can easily calculate the number of moles of product. So we'll reach here. Now comes in case we are given volume of reactant. We all know the universal gas equation, universal gas law. So volume equals to what volume comes out to be here, nRT by tell me P, right? So volume of reactant, if we are given volume of reactant, so volume can be multiplied by V into reply me P upon RT, right, equals to number of moles of reactant. So from here, if volume of reactant is given, so we'll multiply it by given pressure upon universal gas constant, that is 0.08 something a liter atm Kelvin inverse mole inverse, and temperature in the respective units, right, according to the universal gas constant and the pressure we have taken. Volume of reactant, so from here we'll obtain the number of moles of reactant against stoichiometric coefficient of reactant. Stoichiometric coefficient of product is known to us. Number of moles of product can be calculated easily. Again, after we have calculated number of moles of product, so we need to calculate volume, so we multiply it by RT by P. You can verify from universal gas equation or universal gas law. So volume equals to N into RT by P. We have got N. We'll multiply it by RT by P and we will obtain the volume of product. So this is the basic stoichiometry. If you reach here, you know the basic mole conversions, then you can reach anywhere in this map. And you are asked nothing but all these things in stoichiometry. Nothing would come except these, right? In next video, I have already made a video on conversion of mole conversions, which most of the students find difficult in the simplest way possible. Do watch it. Thanks for watching. Do like and subscribe.